We'll now start the round table. So we thank you all the speakers, the 5 speakers of this session that allow us to have a good, interesting overview of the different aspects of data sharing, the different scale in data volume, but also at the different level, from collaboration or the very large infrastructure. So I think it was a very interesting to have all these different point of view of the data and tool sharing. And so now we propose you to have a discussion about the parallel between the sky monitoring and the Earth surface monitoring and the imperative needs of data sharing in both domains. So for the round table, we welcome Matteo Barsuglia that will lead the discussion with Eric Chassande-Mottin and Jérôme Gaillardet from IPGP. So Jérôme is involved in the critical zone building and is developing this concept with colleagues. So he will explain us what are the specificities of this domain, and Eric and Matteo are involved in the gravitation wave astronomy, and also they're very active in the follow-up of the gravitation wave events, so in links with all other wavelengths and other messenger. So Matteo, I let you start the discussion, and then after there will be a session for questions.
Thank you, Anne. Just a second, give me a second and we start immediately. Logistic problem.
Okay. So I can perhaps use this small time to announce the next session for tomorrow. So the third session of this school will be devoted to participatory science. So really the interaction, direct interaction with citizens, and we'll start at 3 tomorrow. But for now, I think Matteo is ready to start the roundtable.
Yes, so thank you, Anne. Thank you for this opportunity to exchange about this very interesting and crucial topic, and also to compare the challenges, the protocols and practice in our communities. So for this round table, we have discussed among us a little bit about how to give a different point of view with respect to the presentations that have been given, and the idea is to raise a few questions, a few big questions that are common to geophysics, to earth sciences, and astrophysics, about the need, the imperative need of data sharing, but making a step back and trying to understand better which are the motivations and the problems raised by the data sharing. The organization of the roundtable will be the following. First, I would ask Eric and Jérôme to recall the context of Earth and space monitoring and data sharing. So trying to raise, try to discuss briefly the methods, the big questions, and yeah, the particular context of space and Earth data sharing for the sky and Earth monitoring. And then in the second part, after, I don't know, let's say 5 minutes each, I think we can debate a little bit about these first interventions. And then in the second part, I would try to raise a few questions. I would try to give, to propose a few big questions. And this will hold for another maybe 20 minutes. And in the last 20-25 minutes, we will have questions from people listening. So I would first start with Eric. So if you can summarize in let's say 5 minutes what is the context and challenges in the sky monitoring and data sharing.
Right. So I first want to make a disclaimer here because you know, I'm not in the field since the beginning of open science in astronomy, and I don't have the full complete picture of this, but I would say that astronomy is probably one of the earliest fields that took this perspective of open science. We heard from many of the talks earlier the mention of the Virtual Observatory, and I think this has been a model and a reference for open science for quite a long time. Probably Catherine knows better the early times than I am, but I think the Virtual Observatory is something that started probably with maybe with internet, like in the 90s, and I think the need was and the starting point was that you know, astronomers observe objects in the sky, and they observe at different times, they observe in different manners, and it helps to have a single place where you can collect all these data together so that you can survey those objects in at different periods. You can also have multi-wavelengths type of observation, and therefore you can do more science. And I think you know, the Virtual Observatory is a real success of astronomy today because of this wealth of data it offers to the broad community of astronomy. I think it started also with, I think it was binded with the model, right? With the model of sharing data and the property of the data. And I think this may be something that we'll discuss more later in the big questions part. And I think a second era, I would say, is starting very recently with, I think, the push from the funding agency to you know, bring the concept of open science more globally in science, right? So I think there were initially a kind of start from a need from the astronomer to have those data together, but then also from the top, from the funding agency, the I think there is a clear message now that open science is key for the future of science. And I think this brings this concept to a broader, possibly community in astronomy that maybe was not covered by the Virtual Observatory, and therefore the emergence of projects like Escape now that are, taking this concept of a virtual observatory, but to non-photonic observation and this kind of thing. I don't know whether I have done my 5 minutes, but I think this is the broader context.
You can continue if you want.
I can continue. Well, I think I said the basic message that I wanted to give. Maybe I could conclude by saying it's interesting. It will be interesting to see how these two lines, right? The need from the communities and the model that is being politically pushed by the national and international European institution will meet together and will bring probably some new way of doing astronomy, of doing astrophysics in the next decade. I think that's an introduction, right?
Okay, thank you. Thank you.
There is a small comment by Catherine. Perhaps we can take it, or
yeah, it's two short comments to Eric's remarks. The virtual observatory is not it is a one thing, the one we're speaking about, the IVOA, but you have also the Europlanet, the VESPA, Virtual European Solar and Planetary Access, who are virtual observatory, but they realized some time ago already that their data were too much complicated that they cannot fit. And they developed a parallel path, always in communication. So, I mean, putting data public is not so easy. And planetary science and solar science is also astronomy. So just to say it's a bit more complicated. We have a great achievement with the classical VO, but there are also side paths that meet together. And the other thing was that the ANR, for example, the agencies now are asking you to have a data management plan in which you have to say how you will provide your data, how you will label them, put enough metadata. They ask you to fill a lot of paper now, just because you have data with your stuff. That's it. So it's just to complete.
Thank you, Catherine. I think this was a fair remark to say, and yeah, thank you.
Okay, thank you. I think we can have now an introduction by Jérôme. Jérôme.
Hi everyone, can you hear me? Yeah.
Yes, very well.
Yeah, so I'm here as a representative of the OZCAR infrastructure, and if I may, I'd like to share 1 or 2 slides. Do you see my screen?
Yes.
Yes.
Yes, so the critical zone is, so OZCAR is a research infrastructure which is collecting data on the critical zone. So the critical zone is a scientific initiative, let's say, which is to consider actually the surface of the Earth as one of the major interfaces of the planet, fueled both by solar energy and internal heat of the Earth. So it's critical because it's a system that we don't fully understand. And in particular, it's critical because it's covered by different disciplines, which have very different histories and which have difficulties in communicating to each other. And it's a critical issue because this critical zone is actually the human habitat on the planet. We're not living on the globe, we're living on a very thin pellicule at the surface of the globe. And if you look at the different disciplines which are interested covering this thin pellicule at the surface of the Earth, it's very easy to see that they don't share the same language, they don't share the same data, and this is not what we need. And if we want to answer this question, this very big scientific question, which is how can we quantitatively predict the response of the Earth's surface to natural and human perturbation, which are going to occur in the next centuries, we need to get a more integrated understanding of the critical zone. And the previous slide was showing the different disciplines are coming from very different scientific fields, different scientific cultural backgrounds. And it's very difficult to share data and information when you have a lot of people trying to study the same object, but with different tools and different concepts in mind. So the OZCAR infrastructure is one of the French national infrastructure, which is trying to put all the observatory interested by some parts of the critical zone together. And so it has been funded by the Equipex Critex in particular. So Critex still is a program of excellence for developing instruments which will be common to different communities to ausculting, to exploring the critical zone of the Earth, which is very badly known. For example, if you look at what is the depth of the critical zone, we don't really know what is the depth of the critical zone in many places, and we don't have the geophysical tools to study that in details. So I'm not going to enter into the details here, but just to say that if you want to study the critical zone, you have to put data together which are very, very different. And basically, if you want to have an integrated and holistic understanding, if you want to build models trying to predict the behavior of the system as a whole, in a changing climate, in a changing human pressure in the Anthropocene, you need to have a lot of data, but we don't have the integrated models. The model has still to be built. And so we need to collect data. We know that we need to collect data, but we don't know exactly which data we need to collect. And each of the disciplines has its own data corpus. And here I have put a couple of data bases that we need to have in order to predict the response of the critical zone to human and natural changes in the future. We need to know something about the soil. We need to have data about the air, the habitats of the particular the biodiversity. We need to be able to make energy budgets, water budgets, matter budgets, and the more difficult is probably to integrate the socioeconomic data such as demography and economic data, human data. And so this is what we are trying to build both at the national scale and at the European scale, because we are now part of the ELTER infrastructure, which is a European S3, which has just started. And so this is a big challenge to be able in the future to put all these data corpus and communities together to have a better view, holistic view of the zone on which actually humans are living on Earth. And so it's a problem which is classical. We need to have interoperable data. We need to share the same language, etc. And I think we're gonna talk about that in the following. This was my introduction.
Okay, thank you very much. Eric, any reaction about that? I have a few questions, but I don't know if you want to react about the differences in models and needs. So I maybe move given this introduction to the second part of the roundtable. And the first question I would like to ask to Eric and Jérôme is, and I have also the impression that we have some differences already from the presentation on what Eric said and what Jérôme said, is who wants, who needs and who wants the data sharing, the open data? Is the scientists, or are the scientists, or are the governments?
Can I start?
Sure, go.
I think I would say it's both. So we are in the process of defining what are the users and the famous stakeholders. Who is taking care of the data that research is collecting? For the critical zone, one specificity that you have data which are collected by scientists, but you also have data which are collected by operational agencies. For example, water agencies are collecting a lot of data every day, everywhere, for example, in France or in Europe, about water discharge, soil moisture, etc. Satellite data are providing a lot of information. And the research and the data from the research, it's always very difficult to know exactly what they are going to be to use to. And my personal impression is that there is a big gap between what the scientists are in need and what the policymakers are in need on data. And the more pessimistic view is to say that the policymakers absolutely don't care about the data which are collected by the scientists, because maybe they don't want to see them, or maybe they have their own secrets and they don't care about what we are collecting as data. So we need to educate the policymaker on, particular on the whole system approach. We make the policymaker aware that, you know, if you change land use, for example, you are going to change the chemical composition of rivers, and that everything is connected. And this is something which I think in the policy making in Europe in particular is not very easy to do.
Thank you. Erika, any thought?
Yes, so, well, I think I have a slightly different perspective than Jérôme here, because so I can speak for the project where I am, and which was presented by Agatha earlier, so this Gravitation Wave Open Science Center. And this service was started something like I think five to 7 years ago, because there were an impulse from NSF. It started in the US. There were an impulse for NSF that required the LIGO project to release their data publicly. I think this would not have happened without this impulse, and or it would have happened much later on. I think the reason for the NSF to make this requirement, I'm not sure of the details here, but it could be that it's some higher up requirement that publicly invested money should benefit to the citizen eventually. So that there is a policy that that I think we are observing now in Europe and in France. I think you heard Catherine earlier saying that now when you get a project funded by ENR, you are mandatory it is mandatory for you to release the data, or at least to have a plan for releasing the data produced by the project. We see now that there is a political view of that the publicly funded data should be made public, and this has a direct impact on how we do science. And first of all, because if we to produce data, then we have to figure out how to release them, and second, because the data are available, maybe you would do a different science than if they were not available. So I think both aspects should be taken into account. However, right, so I think you realize that when you put data online, and this is to finally address, I think, both sides of your question, Matteo. When you put data online, you see really people using it, and that's amazing.
You what?
You see people actually downloading and using it, and using it for things you would not have thought ever about. Okay, so it's very impressive in a sense to see this happen. You should not minimize the possibility that putting some maybe marginal, what you think is marginal data public, it may have an impact on people. People may use it, and so.
Eric, do you, in the model of, for example, gravitational waves, of course, there are two kinds of data, no? There are data that you put in real time, the alerts, these are data, and then there are the complete set of data. So I guess I think everybody realizes that the alerts and some data in real time to allow the electromagnetic follow-up is an imperative. There is an imperative need of data sharing there, and this is there are no objections, no resistance, no doubt about that. And I think I'm just trying to put to explain better for people not completely knowing, and put a little bit of context. So the electromagnetic follow-up of GW170817 was done thanks to an effort of sharing alerts. So this is was very, very, very important, and also recognized as scientists that and you was one of the main actors about this effort. So it's this is something that it's there are no doubt about that. So I would see that the need to share this particular data is from the scientists. The pressure to share the whole set of data in our case was from the agencies. Is it correct?
That's right. So yes, I was referring to the data that Agatha was presenting earlier, right? The data that we put we are publishing on the WOSC, and in a sense, this data, is not related to any particular project or aim, right? The alert, you release an alert because you hope that somebody will take the alert and turn some other telescope and maybe observe something. There is a aim here when releasing the alert. Here we put data because we have, built this huge observatory, this fantastic instrument. We spend, hundreds of millions of dollars or euro in this, and these are precious data, and we release them because they've been publicly funded, but without, any aim in mind. And I think what's fantastic is that by doing this, you create new science that you did not expect. And I think that I find this fascinating.
I would have try to have a reaction about that also from Jérôme. So I have the impression, but I'm simplifying a little bit, that there is the alerts, and the alerts is an imperative need to maximize the scientific outcome of the gravitational wave observation, because without the alerts you cannot have the electromagnetic follow-up. And this is, in some sense, is combining data. And I have the impression this is similar to what is done in earth scientists, what Jérôme presented. So the alert, the sharing of information is essential to make some science. Then there is another part, which is the full set of data, what Agatha presented. And in this case, it's a little bit different. So because you have your own instrument, you want to do science alone. I mean, you can, or at the beginning, for some time after the data taking, you will do some science only with gravitational waves. So maybe I'm wondering if in the earth sciences, there are examples where people is building a new instrument, and there are models where the data, there is a proprietary data. So I don't know if, for example, in the Martian seismometer InSight, there are systems like that. The data are analyzed by some owners, and then they are released. So are there different models in earth science like that, Jérôme?
Oh, yes, I think you can find plenty of examples. For example, people have developed recently very precise gravimetric measurements, absolute gravimetry. So you measure the very fine variation of G on Earth, and it's give you information, for example, for the amount of water which is stored in the critical zone. So it's interesting for not only for geophysicists interested by measuring fine variation of G on Earth, but it's also useful by hydrologists who want to know how much water can be stored at a given place. So it's important for this data to be released and to be publicly available, because of course they can be used by other communities. But again, there is a traduction process which is necessary, because when you are an hydrologist, gravimetric data is not the first data set you're going to think of and that you are going to use, in a more evident way. So you need, a traduction. This is really the good name. A traduction, a translation of what kind of data can be used to solve your problem. And this is a major issue, I think, to put science together.
Okay. So I think we had an answer to this first question. So who wants to share the data? So the scientists and agencies. So I think there are different cases, and short answer is both, but it depends on the. And there could be pressure from.
I see 3 hands up here.
Yes. So
yeah, please go on.
I'm not sure. Maybe it's Julien or Norma Graziella first. I'm not sure.
Who's starting?
Julien.
Go on. Yeah.
Allez, let's go.
Okay, thank you. Well, someone mentioned just before that funding agency, they require now that we put up data management plan, which is true, but I would oppose something. It's not used, unfortunately. So, and I would say if really funding agency want to help that, they should not only fund operation of a project. So when you submit a project, they will give you money for the operation. But also if they want the data to be open, they should also fund the services attached to this open data. And I see it is rarely done. So they read the management plan, the data management plan. They say, oh, that's great. But there is no money associated to that. And usually we struggle inside small projects, I would say, to find then the manpower and the money once the data is online for support, for providing good services, uptime. And I would say if there is something to do in the funding agency side, is really to strengthen this side, to say, well, okay, you want to put data open, that's good, and we'll provide some fraction of the money for that. So that's just what I wanted to say.
Thanks. It's an interesting point.
The answer will be we are putting together infrastructure at the national and European scale. So use these facilities. You don't need your own, data manager. You can go and put your data into the infrastructure database.
But I would love to hear this answer, because at least I would have a place and infrastructure to play with. But unfortunately, we will say you can use, and you will have to write a new proposal in order to apply for fundings in that infrastructure. And that's not impossible, but that's a huge burden and a lot of new work to do for small teams, I would say. But you're right, there exists infrastructure. We don't need to reinvent everything each time.
May I comment, because it's following Julien? It's Catherine Boisson speaking.
Sure.
Yes, thanks.
Yeah, I mean, when I say the ANR is asking, it's not the only place, but it's just because we were writing the one from the observatory this morning, because the main places are also to write data management plan. The ANR, you can ask for money for that. That's something you can add to what you apply for when you apply. But that's one answer on the agencies. The thing is that if you don't have facilities, you don't have data. Your data come from somewhere. So you have to go to those people helping. And if you're from an experiment, and I think for me, it was a big shock when I arrived in the particle physics environment. Coming from astronomy, I discovered that the data were not public at all, even not for me, being inside. I can give an example just for fun. It was in Hesse, long time ago. We had the first data from an AGN out, and I asked to get the data points to put in my code. I wanted to model the data points. And I was told that it's annoying because we just don't have them anymore. Can you measure it on the publication? Can't you measure it on the publication? So we've moved a bit. So it's not an easy process, and I think people have to think of putting their data and storing them. And the money can be there if you ask for. Now, ESO, for example, the European and Southern Observatory, since all time, you apply for observing time. You have you oblige now, if you have a long-term project, to put your data public in their website, because it's ESO doing that. So it's more complicated for experiments than for observatories, I would say, but that's something which should not be impossible to do, organize and have. As Eric said, for LIGO Virgo, it was possible to, at least for LIGO, to organize a place and give at least the alerts and even the data after that. So I think it's just that we have to get used to do that.
Okay, any other reactions?
I have a question, if I may.
Yes, I have with my hand. So,
Yes, please, Norma Graciela, please.
Thank you. I am a little confused. I mean, about the answer, some answer provided, and would like to, in some sense, to ask for clarification, or to clarify. I mean, or to try to clarify. The title being Open Data and Unexpected Events, and the two examples provided, I mean, gravitational waves, and the other, the geophysics, I mean, Eric and Jérôme. and we presented in some sense, and we can understand also from their own fields and experience, two different points of view, which Matteo tried to make as a question in the reaction, or trying to conciliate or to explain the two different views. One, Jérôme, policymakers are not going, in some sense, are not going in the sense of scientist demands and scientists' interest, or what scientists want, make it clear, and Eric answering the example of LIGO, Virgo, gravitational wave, etc., which Matteo put it forward very clear also, in a different way. And because gravitational waves needed and benefited from those sharing or opening, and helped, to all the discoveries or progress. These are this is because there are different fields and different kind of interests, perhaps, from the policymakers and the agencies and so on. And I take into account also the contribution from Catherine, which explained it, or who explained it also from the high energy physics and so on. I summarize. So I take another astrophysical or cosmological example, which is the spatial cosmology missions. From that point of view, it sometimes is we can understand that the teams who made a lot of effort and a lot of input to build and make the concept of the instrument needed to or want to analyze the data, to make publication, to have some benefit. I am saying that. I am not an instrumentalist, as you know, and I am theoretician working with that, of course. And so we can understand that. This is, for instance, plan mission said for the last. There were another from NASA, WMAP, who shared from the beginning the data. And the impact was very, very, very strong too. So the point being that after some while, the data must be public. Now, is that an answer to the two different point of view, which I liked? I learned here were expressed. I don't think so, because these are different kind of interest. Interest in the sense of all what policymakers mean. So I understand the geophysics point of view. I understand that it could be very difficult in some sense to go in progress. So all the issue is that it's evolving. Is the reason why we are discussing here. But for the particular physics, as Catherine put, particular physics has a long tradition of what is sharing or not sharing data. It was, but I think that being public, there is a duty to make data opening. Doesn't mean that I want to emphasize too that the word, because the title have two parts, open data and expected events. Not all branches of physics or of science work well with unexpected events. Of course, unexpected is open mind is very good, but to have a benefit from science, we need also targeted program, civil. We know clear ideas too. it's not all left to unexpected. The nature will not do the work for us if we, I mean, for our gold instrument, if we don't pay the effort to clarify the issues, to make discoveries. I think that is also important.
Okay, thank you, Non. Anna,
if you want to react, I take your reaction, of course.
Any reactions from Eric, Jérôme?
Yes.
Then we have Anna, or
Anne, yes.
Anna and then we move to the other questions we prepare. Anne, please.
I was wondering, since for critical zone, it looks like even more difficult because it's completely interdisciplinary topics. So people from different fields. I mean, science and knowledge has always been organized in a different field with people really with a common language and specialized in a very well-defined domain. And then when you want to exchange between different domains, and of course you don't have the same vocabulary, the same way of analyzing, using your data. So you were talking about the translating of the data for that they can be used by others. So how you do that when you have to discuss with people that are not in the same domain as yours?
Well, I don't have the I don't have the recipe. I think it's something we should do. I think it's something we should do as scientists. If we want to make a big voice to the people and go to the stakeholders and the people that decide for policy making, we should have a common voice. And this is not the case. And this is, I think, in environmental sciences, and the reason why a lot of people get totally confused by what is happening on the environment in general, like climate change, biodiversity, soil health, etc., is that the science is not providing a unique and clear, message. Different communities have different databases, different languages, as you say, and it's very difficult. And I would add something which is more difficult, which is that the way we do science is not the same depending on the communities. So, for example, I'm working with socio-ecologists, and the socio-ecologists, they co-design the scientific questions with the stakeholder, which is not the way we, physicists or earth scientists work. Okay, we have our own scientific questions, and we don't think that the public can be of help to define our scientific questions. But when you're working, for example, of nitrate contamination of aquifers in Brittany, for example, you need to take the farmers into account because they are the main actors on your problem, So, and you can experiment with them. You can do citizen science. You can, so in a way, part of the community, which is a socio-ecological community, think that the scientist is just one member of a long chain of people which are connected. And so it's a very different way of doing science in a way.
Thank you. Yeah, let me move to another question. So if I understand well, there is consensus in saying that the data sharing, open data, increases the efficiency of science. So let me continue with some provocative questions. Is always the case, or in some case, sharing the data, and we had some reactions at that, is decreasing the efficiency of the science, of the scientific community?
That's a very provocative statement after the day we had, in fact. And I would say that so I think the first basic answer is that there are surveys for this type of thing. What you gain by opening data. I think by Googling open data benefits, there you find survey by the OCDE, OEDC in English, that shows that I mean, on the top of my mind is that it was estimated like you can gain billions of dollars per year by opening the data. And the reason for this is that, first of all, you by sharing data, you avoid loss of data because digital information is very volatile. And if you lose your hard disk, like in the 80s, where you had your thesis, then you lose your thesis. And it goes with all digitalized data today. So this is the first impact that you mitigate by opening the data. Minimize the risk of loss. And also you minimize the risk of duplication. I've read that in some fields, people are basically redoing experiments because they don't have the data that are needed for them to do their own science, right? So by opening the result of your own experiment, then you allow the other not to redo your experiment to move forward. So here you probably gain in efficiency. I mean, you gain in efficiency. I think it's demonstrated, and this is why I think it's so successful at the agency level, because it's an economy for them, right? So it's a way of doing more science with less money. Right. So now, and I think this is where maybe a comment made by Norna earlier is relevant. There's the way community are working and how much effort they put into generating data. Of course, as she said earlier, if you spend 20 years of your life building an instrument and you're not on the paper that make the discovery with this experiment, you're angry. I mean, you're not happy. And so probably there is something there that right, that need to be thought about. And I don't think today we have a perfect solution to address this kind of problem. So here, probably, this is something that is very current in the LIGO and Virgo collaboration, where we need to revise our open data policy. And we need to think about the duration of the proprietary period. And there are two basic effects, right? If we make the proprietary period shorter, then this allows other groups to make science with the data faster. But this put pressure on us to make our own results. So people will leave the collaboration, and therefore the instrument and the science we do will be worse. But on the other sides, there will be more science done outside. So what you do? There's probably a good trade-off here. And this, I must say that I haven't seen anything that address this quantitatively. How do you optimize the sweet point?
Eric, why there are fields like astronomy, and Catherine was mentioning the shock she had when he went to the high energy physics community, moved to high energy physics community. Why there are fields where it's normal to share data immediately, and there are fields where it's complicated?
I'm not an epistemologist, and I don't know, but
it's a question of a tradition, or there is something more.
I think it's purely cultural. I think it's purely a decision of few people at the beginning that thought, well, this is it. This is how we're going to work, and we'll see how it goes. I think it may be the way science is funded as well, right? Probably that's a good question for epistemologists. I don't know if somebody has some in there who was determining this. I don't know.
Jérôme, any reaction about that? Why there are fields where it's natural to share the data and other where it's more complicated? I mean, I have my personal answer is related to the needs to share the data because it's useful, and also to the investment you are doing, and to the motivation of the scientists behind, for example, the development of an instrument. I mean, if you develop a new instrument, you want to be the first to use it, probably, and also the agency wants to be the first to announce the discovery. It's probably related to that. This is my answer, and also the motivations of people developing the technique of the instruments. But maybe there is something else, as you said. Maybe there is also a cultural issue.
My impression is that when you spend like 10 years of your life developing, the most precise isotopic measurement that you can ever find, you don't want the data to be put immediately on a public database. But if you're working on data which are more easy to measure, then the problem is less important, and you are willing to put your data on a public database. So this is what is happening in my field. When you're measuring, like, I don't know, zinc isotopes in a meteorite, you are the only one in the world that knows how to do that, and you are the only one in the world that know how to use this data. You don't have a problem of putting that in a database. You don't mind, and so you need an embargo period on which the data will be on your own computer, and then after you publish your Nature publication, you can release the data. So there is a lot of discussion about what should be the embargo period, actually.
Thank you. Anne, you have a question or a comment?
Yes, thanks. I just wanted to make a comment, because in the gamma ray field at very high energy, we are on the transition between private data with all the instruments that are now finite in their life now, and the new observatory, which will be CTA, which will be an open observatory with open data. And clearly this is, the transition is now that the field is really mature and the technique for detection is completely mature, then there is not so many problems to share the data. But before that, of course, yes, as you said, Jérôme, we were more closed about to the stronger the detection techniques, and so there was so many work on instruments that it was really difficult to share the data soon after the observation. And that in that way, the gravitational wave domain has been very quick to share data.
Anna, can you remember the timeline, which is the timeline for the gamma ray astronomy? So after how many years you are finally able to share the data immediately and to become an observatory?
So actually the first gamma ray, very high energy gamma ray detection started in the 80s for the first source detection, and then the field went mature like at the beginning of Veritas S and Magic Observatory, so instruments. So in the 2003-2004 years, and now it is 15 years later. Then we are building. I mean, we already started to build the CTA a few years ago, but yes, so it took some decades to be accepted by the community, and it's still difficult.
And probably here there is a cultural push by the astronomers, because if I understand well, the high energy physics community is older than the gamma ray astronomy, but there are still the proprietary model. Is it correct? I don't know, Catherine, if you want to comment on others.
Yeah, I can comment on a few things that have been said. Yeah, I'm not sure we are those pushing and saying I think the main difference, and it was said by many people before, is that an observatory is paid by agencies and not only one or two bipartite between labs agreement, even if they are international. Here it's really countries going together and putting money. We have in France the TGIR system to finance big project, and that's the difference between experiment and observatory. And if you're an observatory, you expect the data to be public. And in observatories, the data are not public as soon as they're taken, for sure. Depending on the field, depending on the frequency, it can be 1 year, it can be more, but even if a date is given, a timeline is given, you can always apply for keeping your data private longer, because you have some other, I mean, multi-wavelengths going on or thing like that. But I wanted to come back also on the development of instrument. If you build an instrument for ESO, for example, one of the VLT instrument, you will get guarantee nights, guarantee time, and this time you preempt the objects you will be observing for a certain science, so science plus object, and you have a guarantee time which is quite long. So not guarantee time, sorry, proprietary time. So nobody will see your data before the software to get good data out will be ready. And the data are stored at ESO, but they are just, you have this system of authentication and things, you cannot access them. You know, data have been taken, but you cannot access them. And it can be a long period as long as the software is not ready. And now you have, even if your data have been, you have built the instrument, you have written the software, you have to give the best software to ESO. And you have also to give, if you have a long, what I said before, if you have a long term project, the data will not be public every year after one data is taken. It's at the end of the long-term public project. 1 year later, your data will be public. So those are the long-term project. And then you have to give the added value. You have analyzed the data, you publish them, you make catalogs or just publication, and you have to give these new data into the database. So the people have not to reanalyze the best value the data. But to come back to Anne's comment, yes, I think it's just because, I mean, there are more people paying for that. And they want to have the data back. And yes, astronomy being in, that was for sure we were asking. But for CTA, I can say, because I was in the round, that at the beginning, it's not the astronomy you ask for, the agency above. And we had the Werner Hoffman coming and saying, you sure, we have to put the data public? And at least France and Italy said yes. There's no discussion on that.
Yeah, but if I play the devil's advocate, the CERN is taking a huge amount of public money, and I don't know the details of the model, but So why for the CERN there is not an observatory model for the decade? Enrique, you're not, I cannot hear you.
There were an announcement this week, right, by the president, I mean the director of CERN. Yeah. Which says that they will release data. Okay.
Maybe I can say something.
Right. So can you explain? I mean, you know probably better than we do.
Sorry to jump in.
Sure.
Yes, so I'm not speaking on behalf of CERN, but still I know as an insider, we had the same push from the Americans, essentially, about at the same time as you, about more than 5 years ago or something. And of course, we were all very reluctant, but slowly the whole thing went into the EU, and now we had a long discussion about what to do. So yes, there is this data policy announcement, which is the result of long negotiations. One thing I'd like to stress is that there is one field in which we are very different, which is the publication policy, the authorship.
Sorry, Claire, can you say what is the announcement exactly?
Okay, so we had the same push to release our data from the management, politics, and things like that. And so the CERN directorate set up a working group to put the LHC experiment around the table and to discuss, to find an agreement. Because actually, one of the experiments, which is CMS, is very strongly, had a much stronger push than my experiment, which is Atlas. So this is kind of internal debates, I would say. So in the end, there is a general policy that at the end of the experiments, all data will be made public, which doesn't cost much because the end of experiment for us is in 30 years. So, so the question is how much we release in between. And the idea is the time scale is going to be more or less 5 years after data taking, and with a subset of data. And it will be calibrated data and things like that. So this is the kind of discussion that we have internally to have some of it. The fear, as I mentioned before, is of course that some people take the data and discover a kind of new physics thing, but we had the perfect answer. Yes, it's true, it's science. Now, from my expertise, from my impression is that internally, the frustration and the worries are really linked to the visibility, the authorship, the signature, and also the impact it has on the career of young people. Especially the one who go from one postdoc to another and have to show every second year that they have an impact on the science and things like that. So many of them are really doing all the calibration or the technical things. And we have this very funny habit to have everybody signing at the same footings. If you look at our papers, we have 3,000 people signing listed alphabetically. So you cannot tell the difference between the guy who is the smart looking for the Higgs boson and the guy who did all the calibration of the data. So the idea to release the data and to have people using the calibrated data creates lots of frustration, and it really has an impact on how we see the careers and how we see the visibility in these huge experiments. This is, I think, a sociological problem. As more than a real scientific problem, because we all more or less agree that if we release the data 5 years after they are in our hands, most of the juice and most of the physics we want to do will come out. So now there is one thing that is not mentioned, but maybe in the discussion, maybe it's for tomorrow, it's the education part. All the masterclass, all the way to pull in university students in our world, which is really linked to open data, because at the moment we cannot do any exercise based on our data because they're not public, but maybe it's for tomorrow.
Okay, thank you, Claire. So let me say that we have to finish, to conclude. So first of all, a quick reaction to what Claire said, Jérôme and Eric. Eric, you were smiling.
Well, the 30 years of preparatory period is yeah, I think it's funny, but it's not a commitment, right? But again, I think we are there to the I think to a question that I think I will try to study at some point. How to, is this 5 years, for instance, something probably coming out from discussion between people, but is there a quantitative way to assess that it's the right decision that you're making? I think this is interesting. It's not an obvious question. I think there are many factors. Probably you need to make guesses. You need to make ballpark estimates, but it's probably something that now we have this policy, right? Now that, as you said, we have this pressure from the top and from the policymakers that we need to release this. I think there should be some guidelines and quantitative guidelines that can assess how it works and how it works best.
Okay, we have a few minutes, so I would like to conclude with the last question and quick reactions from Jérôme and Eric. So, is the data sharing important for the reproducibility of the scientific results? So it's something important in science to reproduce results is an aspect that it's important. So open data are important for that. So for example, in Virgo and LIGO, so other people analyze Virgo and LIGO data. Is important that apart the LIGO-Virgo collaboration, other people analyze the data, or we were sure about our results?
So we discussed that earlier, and there were some comments and questions by Claire after Agatha's presentation. We had papers of people that were contradicting our conclusion. And the fact that, well, of course, the fact that the data was open and people analyzing it allowed this contradiction in a sense, right? Somehow these people were trying to reproduce our result and were failing to do so. And I think we learned something out of this crisis in a sense, right? So we learned that we were missing to communicate some of the knowledge in our paper. We were giving the result without explaining the process. And the fact that others was failing to reproduce our result has led to us releasing another paper detailing what's important in our processes to reproduce the thing. So I think it's really all about science. And I think so this is where I'm deeply convinced that it's essential to release the data for this very reason, although it's a pain it's a pain to explain things again to people that may not be completely aware of what they are doing. But it's it's, as a scientist, I think it's our duty to make this process transparent and as much as possible. Of course, in our fields, reproducibility is limited because it's limited only to analysis. You're not going to reproduce Virgo in your garden. You don't have room for this. And so, well, you do what you can, right? However, there are other fields, and I think when you speak about the reproducibility crisis, I think you may refer to a Nature paper that was published a few years ago. That was very that you could have read in the papers and so on, saying that I think in certain field the reproducibility percentage, in particular in medical science and in biology, is an amazing number. It's like people able to reproduce less than 10% of the paper published. So there, I think it's essential. I think this open science business is essential because because you cannot, I think, operate as a scientific field in this situation.
Jérôme, do you want to comment about that?
Oh, I just wanted to say that when you are looking at the Earth system, there's no way you can test the reproducibility. I mean, we're not doing experiments, so we're looking at the natural system. So in a way, the natural system is reproducible, but it's never the same, actually. If you have two earthquakes, they will never be exactly the same. So I don't think this is an issue in earth sciences or environmental sciences.
Okay, thank you. I think we have to close the round table. Thank you for this opportunity. So Anne, do you want to give a...
Very much. Thank you for the nice roundtable and discussions. And thank you to all speakers of the day for the very interesting talks. So of course the topic is very large, so we were not exhaustive, but I think we had very interesting interaction during the afternoon. So we will close the second session of the school today, and we will meet again tomorrow at 3 p.m. for the participatory science aspect. Thank you to everyone.